Hi class, I'm going to do section 1.4, basic notions of functions. This is part 2. Okay, I hope to cover these topics today. Um, the previous topics I covered in part 1. Today in part 2, I'm going to cover these topics, independent and dependent variables, vertical line test, uh, combining functions, composition, uh, decomposition. This is composition and decomposition of functions. Functions of several variables. Uh, and calculator tips, this one is same as what we learned before. Therefore, we don't need to do this one. All right. So this is already done. Um, okay, let's move on. Independent and dependent variables. Usually the elements in the domain is the x or independent variable, and the elements in the range um, is the y variable that depends on x. Um, uh, okay, vertical line test. A graph represents a function if and only if any vertical line intersects the graph in at most one point. That means if we consider this blue line here, this line, um, and look at this dotted black line. Um, this dotted black line is our vertical line. If the vertical line intersects the given graph more than one point, it is not a function, right? If it intersects one time or no times, means if vertical line not intersect the graph or intersect only one time, then only it is a function. Now look at this first one. It intersects the graph at 2 points here and here. Therefore, this is not a function. How about this? If you draw a vertical line anywhere, just imagine you move this vertical line, this dotted line from left to the right. It never intersects the graph more than one time. Always it intersects the graph just one time. Therefore, it is a function. How about this? Same thing. If you move a vertical line from left to the right, it intersects just one point. Therefore, this is a function. This one, horizontal line. Still, the principle is the same. If you move a vertical line from left to the right, it intersects only one point. Therefore, this is a function. This one. This is a vertical line. Now, look what happened if you move a vertical line from left to the right. This is a vertical line. Now, it does not intersect any point of the given line. This is the given line. given function, we don't know if it is function yet. Given line is this. Now, as this red line moves on, um, it's not intersecting until it comes here. When it comes here, means at the time they overlapping, this vertical line intersect more than one point. In fact, it is uh, intersecting infinite number of points because they are overlapping. Therefore, this is not a function. This one, if you draw a vertical line, here it intersects only one point, but if you draw a vertical line here, it intersects 2 points. Here, same thing, intersect 2 points. Means if you could draw a vertical line anywhere which intersect the given graph more than one point, it is not a function. Therefore, this is not a function. All right. Okay, let me erase these lines. Okay, let's do this example. The fare for riding a cab in a small town is uh, follows: $150 for the first mile or the part, and $250 for each additional mile or part. Uh, Part A, determine the equation that describes this function. B, what's the fare for a ride that is 5 miles long. Uh, C part 8.3 miles long. Okay, let's start with part A here. If D less than 1 mile, let me this thing. If the distance is less than 1 mile, then the cost is equal to 150. If D is greater than 1, what would be the cost? Cost equal to, for the first mile, he has to pay 150. Now D is greater than 1. For the rest of the miles, he has to pay 250. So for the first mile, it is 150. The rest of the mile is D minus 1. For this, what is paying? Is paying 250 per mile. Now, if you simplify this, this is 150 plus 250 d. I'm distributing this minus 250. What we get here? 150 plus 250. You can combine these two, then we get 250 d. 150 minus 250 is negative 150, negative 1. 2, 150 minus 250 is negative 1. Therefore, we can write this function, which is part A, determine an equation that describes this function. You cannot write it in write it as one equation. Um, that function consists of two equations. The cost function, which is depend on d. This c parenthesis d means c as a function of distance. We can write this as cd equal to 150 if d is less than 1 and greater than 0, 0 less than or then d equal to 1. If it is 1 mile or part of 1 mile, less than 1 mile, he has to pay 150. We do not write equal to 0 because if we didn't go 0, if we didn't go any miles, if we go 0 miles, he doesn't have to pay anything. Now he has to pay 250 d minus 1, this amount, 250 d minus 1, if d is greater than 1. Okay. Right. Part B. What is the fare for a ride that is 5 miles long? Okay. Keep this in mind. Let's do I have a blank page, so I'm gonna do. I want to keep this equation, so I do part B on top here. If it is in part B, five miles long. If it is 5 miles, first 1 mile, it is 150 anyway. The cost is equal to cost for 5 miles. This is equal to B. Now, if it is greater than 1, we have to use this second second equation. Second equation. Um, so it is what we use 250d minus 1. Um, d is 5. 250 times 5 minus 1. 1250 minus 1. 1250 minus 1, which is $11.50. Okay. In part C, it's similar. In part C, it's asking for C. How many miles? 8.3 miles. 8.3. So it is again greater than 1. So in part C also we use the same equation, 250d minus 1. D is 8.3 minus 1. Um, you may take, we multiply this and minus 1. I give you the book answer. Let me see what's in the book. This question is from the book. It is 2150. $21.50. Okay, that is example 9. Okay, combining functions. Functions defined over a common domain may be added. Uh, function defined over common domain, though both functions should have the same domain. Then they could be add, subtract, multiply, and even divide, so long as we do not divide by 0, as we do not divide by 0. Right? Let's do this example. It is not something hard. When we do the example, you will understand. Fx is defined as x plus 2, gx is x squared plus 4x plus 4. Determine these a, b, c, and d. Part A, fx plus gx, fx plus gx equal to fx is x plus 2 plus gx is this one, x squared plus 4x plus 4. At these two, we get x squared plus 4x and x plus 5x plus 2 and 4 plus 6. B. Fx minus gx equal to x plus 2 minus x square plus 4x plus 4. X square plus 4x plus 4. So we get negative x square. Negative 4x plus x is negative 3x. Negative 4 positive 2 is negative 2. That's B. C. Fx times gx. Fx gx, this means it has invisible multiplication in between. It's equal to fx is x plus 2, gx is x square plus 4x plus 4. If you multiply this, we get um, you you can multiply everything in the second parenthesis with the first term and then with the second term. Those who having hard time with that, I advise you to write this extra step. Get the first term here, which is x, then write the whole second parenthesis, x square plus 4x plus 4, then get the second term of the first parenthesis, which is 2 times again the second parenthesis, x square plus 4x plus 4, then distribute x cubed plus 4x square plus 4x plus 2x square plus 2 times 4 is 8x plus 8. Combine like terms, we get x cubed 2x 4x square plus 2x square is plus 6x square plus 4x plus 8x is plus 12x plus 8. Okay, that's C. D part, fx divided by gx equal to fx is x plus 2 divided by gx is x square plus 4x plus 4. Now this one you have to simplify. Uh, let's see if we could factor and simplify this. X plus 2 divided by x square plus 4x plus 4. Factors of 4 that gives us 4 is 2 times 2. 2 plus 2 is 4. 2 times 2 is 4. Therefore, we can factor this as x plus 2 times x plus 2, or we can say it is x plus 2 square. So we can cancel out this x plus 2 in the numerator with one of the x plus 2's in the denominator. In doing that, we assume x plus 2 is not equal to 0. if x plus 2 equal to 0, we have 0 in the denominator. Therefore, this whole thing fx over gx is undefined. Therefore, at the time you cross this out, I cancel out. By crossing this 2, I mean the x plus 2. We have 2x plus 2's in the denominator. If it is not clear to you, you may the same thing you write as x plus 2 divided by x plus 2 times x plus 2, right? Then one of these cancels out with one of these. There you have to write x not equal to negative 2. How do we get this? We say x plus 2 not equal to 0. You don't have to write that one. X plus 2, if you want, you can write it. So I'm writing it not equal to 0. If x plus 2 equal to 0, this denominator is 0. Um, Therefore, we say that x plus 2 shouldn't equal to 0, which means x is not equal to negative 2. Then we get the final answer 1 over x plus 2, where x not equal to negative 2. All right. That's how we combine two functions, add with addition, subtraction, multiplication, and division. Now, beside these four ways, with function, there is another way to combine. Let's see that. Okay, that is composition. You might heard about it. But composite functions. Okay, functions have one additional way of being combined, called the composition of functions. Suppose two functions defined by the equations, one is y equals fx and the other one is y equals gx. The new composite function y equals, uh, you read this as f of g of x is defined when the function y is defined and is the composition of f with g, right? Um, this thing f of g of x is the same thing as composition of f with g. Composition of f with g. Uh, this this thing is the same thing. There I write y equals g of f of x. This means composition of g with f. If f appears first, composition of f with g. Okay, let's move on. Example 11. Let fx equals 2x plus 3 and gx equal to x squared plus 1. Determine um, f, f of g of 3, g of f of 3, um, f of g of x, g of f of x. Okay, let's start with A. Uh, we want to find f of g of 3. We are given, for this, let's calculate this first. We are given g of x equal to x squared plus 1. Therefore, g of 3 equal to, we substitute x with x with 3. Substitute 3 for x. Then it is 3 square plus 1. 3 square is 9 plus 1 is 10. G of 3 is 10. Therefore, we can write this as f of, in place of g of 3, we can write 10. Then uh, f of 10, we know we are given f of x equal to 2x plus 3. Therefore, f of 10 equal to 2 times 10 plus 3, 20 plus 3 is 23. Okay. Part B, it's not different. Do it in the same way. There, calculate f of 3 first. You calculate f of 3. You use this equation 2x plus 3. This is fx. F of 3, 2 times 3 plus 3. 3 times 3 is 6. 6 plus 3 is 9. Then we want to calculate g of f of 3 equal to f of 3 we found this is 9 here. This is g of 9, number 9. Gx is what? G of x is x squared plus 1. Therefore, g of 9 is 9 square plus 1. 9 square is 81 plus 1 is 82. So g of f of 3 is 82. Now, in part C, f is given 2x plus 3. It's the same thing, but I'm writing for your convenience. G is x squared plus 1. We want to find f of g of x. F of g of x. So let's substitute first g of x here. F of, we can do either way. We can get fx and substitute for gx here, or this way. I'm just wondering which way is easy, means more convenient. Let's do it in that way. Okay, let me So to find f of g of x, you substitute gx for x here. It is 2 times x is now gx plus 3. Now substitute for gx, which is x squared plus 1, plus 3, which is 2x squared, plus 2 plus 3 is plus 5. Okay, but d g of f of x. So take gx. Write gx first. Gx is x squared plus 1. Then g of f of x means, see, in place of fx, in place of x, we have fx. Therefore, substitute in the right side too. Fx whole thing square plus 1. Fx is what? 2x plus 3 plus 1. 2x plus 3 square. Square this, we get 4x square plus 12x plus 9 plus 1, which is 4x square plus 12x plus 10. Okay, that is g of f of x. I'm going to erase this and move on. Okay. Complete table below determining the values of f of g of x, g of f of x. Okay, we just want to complete the following table. Let's do that. Okay. Now look at this first element. Let's say this is number 1. Somewhere number 1. Okay. How we find number 1? We want to f of g of x. There, in this first column, let's understand the table. On the first row, it is given x values. So these are x values. This row is fx. This row is gx. Okay, and we want to find composite in the following 2 lines, 2 rows. So in the first column, in this column, its x is -5. So when we calculating f of g of x, this means f of g of -5 . Now let's see if we have G of -5. G column, G row is here, this one. So G, to find G of -5, we have to go G and we have to find X where it is -5. So it's the same column, G of -5. So G of -5, you see from the table, G of -5 is number 2. G of -5. G of -5, which is 2. Therefore, we can substitute 2 for G of -5, and we get f of 2. Let's find out f of 2. F is this row. Let's see if we have x is 2. x2 is here. x2 is here. Therefore, f of this row, and this column, which is this number, equal to what? F of g of f of 2. F of 2 is 7. Okay, let's do another one. So let's fill this one is 7. Let's say this is cell number 2. Let's see if I can erase this marks on the table. Okay. Okay. Let's do this number 2. G of what is this one? F of g of number 2. We want to find f of g of x. Here x is -3. That means f of g of -3. G of -3, g is here. The -3 is here. Then g of -3 is this number, -5. Then we get this one, f of -5. G of -3 is -5. F of negative, to find f of -5, f is here. -5 is right here. That means we have to go on this column. F of -5 is -1. This is -1. Okay, let's find a random one for g of f of x. Should be g of f of x. Let me change that. This should be f. Write it up outside. This should be g of f of x. Right? So let's find out a random cell. Let's say this one. Let's give it a number 1, 2, 3, 4. 4. We want to find cell 4, which is g of f of x. G of f of cell number 4, which is the x value is 0. F of 0. F0 is what? F is here, and 0 is in this column. Therefore, f of 0 is -5. Therefore, we have to find g of -5. Now, go back to the table. G is here. We have to find where x is -5, -5 right here. Right? G of -5 is this number 2. Right? So this should be 2. Um, Likewise, you can fill out this table when you calculate 2, 3 cells. You will see the pattern. Then you can find it quite quickly. I write the answer. Right? Okay, that is example 12. Next one, example 13. Let fx is 1 over x, gx is, wait a minute, I cannot see that it is covered. Gx is x plus 1 over x plus 2. Determine the domain of f of g of x. Now I already wrote here what we want to find out, f of g of x. This exists only if g of x exists, right? F of g of x exists only if g of x exists. Therefore, we say this is to exist. Both f of this should be g of x. G of x. G of x and f of g of x must exist. This whole composite function should exist. Also, g of x should exist. Right? F of x. What do you think about f of x? See this one. This is undefined when x equal to 0, but that does not affect the domain of f of g of x, the composite function. Right? Now, let's see where gx exists and f of g of x exists. Gx is x plus 1 over x plus 2. And in last lesson, we discussed how to find domains of rational functions. Now, you remember I talked about the restriction. Here, the restriction is the denominator. X plus 2 should not equal to 0. Therefore, x should not equal to -2. X should not equal to -2. This is one of the conditions, right? Let's see the other one. This is for gx. Um, for that, we have to find f of g of x. Fx is 1 over x. Therefore, f of g of x is 1 over gx. Right? Then 1 over gx, substitute for gx, we get 1 over gx is x plus 1 divided by x plus 2. So we can write this, flipping this, by flipping this, we get x plus 2 over x plus 1. Now, what's the domain of this? The domain, again, the restriction is the denominator should not equal to 0. X plus 1 should not equal to 0. So x should not equal to negative 1. So we can say, let me move this thing. We can say x is all real numbers except negative 2 or and negative 1. Now, in the way we learn this, let me change the color to, okay. Now, if you do this on number line, we have two numbers. What we want to do, we want to write this in interval notation. X cannot be negative 2 or negative 1. Negative 2 is smaller than negative 1, therefore it should be left to negative 1. That means x can be any value in this direction, this way, or this way. Now, if you write this in interval notation, in interval notation, domain we can write as negative infinity to negative 2 union negative 2 to negative 1 union negative 1 to infinity. Okay, that's how we write the domain for this example in interval notation. Okay, decomposition. Decomposition is opposite of composition. Let's use this example to learn that. Consider the function defined by the equation y equals 2x square minus 3 to the power 10. Find fx and gx so that f of g of x equal to 2x square minus 3 whole thing to the power 10. Okay, f of g of x should be what? It should be 2x square minus 3 whole thing to the power 10. Right? Understand the question. Um, Now, this question again from the book. Um, if you just read this part, that is good enough. Find, if we can say the same question like this. Find fx and gx so that f of g of x equal to 2x square minus 3 to the power 10. Just as this line, right? Um, okay, how we do that? Now, let's say this. Let's take fx equal to x to the power 10 and gx equal to this inside function, which is 2x square minus 3. Now, if you take it like this, uh, now what is f of g of x? Gx is fx is x to the power 10. Therefore, uh, this is g of x to the power 10. Right? Now, if you substitute for gx, we get 2x square minus 3 2x square minus 3. Gx is 2x square minus 3 whole thing to the power 10, which is, that is what we want. That means we can write fx as x to the 10 and gx as 2x square minus 3. But I'm asking, is that the only way we can do this? Now let's say this. This is one way. Now if you take fx equal to um, x to the power 5 and gx equal to 2x square minus 3 is to the power 2. Let's find what's f of g of x. Substitute for gx, g of x to the power 5. What we did, we substitute gx for x. Now substitute for gx, which is 2x square minus 3 to the second power. This is gx, this to the power 5, which is what we get 2x square minus 3, this to the power, exponent to the power, we multiply exponent and outside power, 2 times 5, 10. So again, we get the required composite function. That means we can select f and g more than one way. So there are many answers, many solutions to this question. We can select F and G in more than one way, different ways. Right? Okay, if you get such question, just show one of the ways, maybe this first one, second one. There are many other ways. If you select uh, fx equal to x to the power 2 and gx equal to 2x cubed minus 3, this to the power 5, still it works. Okay? So there are many ways. Also, this exponent could be rational exponents. 2 over 5, 20th power. Okay, we can use that. X equal to 2x cubed minus 3 to the half power. Find f of g of x, you get the same composite function. Likewise, we get uh, infinite many uh, functions for f and g, where the composite is equal to the given function. Right? So you just have to find one of them in case you get such question. Just find uh, just one solution for f and g. Okay, let's move on to the next topic. Functions of several variables. Let's learn this with this example. Suppose the productivity V is given by the equation Z equals f of fx comma y equal to 100, x to the power 1/4, y to the power 3/4, where x is the number of units of capital available and y is the number of units of labor available. Determine F81 16. F81 16. Now look at this. V is a function of x comma y. You see in the equation, if f is a function of x comma y, you see that in the equation for fxy, to find f81 16, what you have to do is substitute 81 for x and 16 for y. Right? Let's do that. F81 16 equal to 100 x to the power, wait, we substitute 81 for x. 81 to the 1/4, then y to the power, y is what? 16. 16 to the power 3/4. Okay, 181 is 3 times 3 times 3 times 3 is 81. That means 81 we can write as 3 to the power 4, that to the 1/4. 16, we can write 2 times 2 times 4, 4 times 8 times 16 is 16. Then 2 to the power 4 is 16. That to the power 3 over 4. Then this 4 to 4 cancel out, 4 to 4 cancel out. We get 100 times 3 to the power 1 times 2 to the power 3 is 8. This is 2400. Okay. That is example 15. This move on to the next page. Example 17. Given c equals x comma y square plus 2xy plus y square, assuming neither h nor k is 0. Determine if x plus h comma y minus fxy divided by h. Okay. Okay. If x comma y is given x square plus 2xy plus y square, right? We want to find out this ratio. Okay, copying again. I made a mistake here. This in the second part, this should be k. So let me cross this out, and it should be k. Okay. If x comma y is given, so let's to do part A. Let's find out. Okay, let me change the color. This part first. Okay, x, that is f x plus h comma y. That is what in place of x, now I have x plus h. In place of x, we have x plus h. Therefore, on the right side of the equation, wherever you see x, substitute x plus h. Is x plus h square plus 2 times x plus h y plus y square. Don't do anything to y. Wherever you see x, this is the x, this first place is the x position. That changed to x plus h. Therefore, on the right side of the equation, we have to do the same thing. Replace x with x plus h. Let's simplify this. We get x square plus 2hx plus h square plus 2x plus 2h 2 2xy. 2xy plus 2hy plus y square. Right, now let's write, there are no like terms to combine, therefore let's uh, write this fx plus h comma y minus xy. That means the numerator, the whole top part of part A, minus f x comma y. Why I have to write this whole thing here, x square plus 2hx plus h square plus 2xy plus 2hy plus y square minus fx comma y is this given equation. I write that here, x square plus 2xy plus y square, right? Okay, let's simplify this. Choose a different color to simplify. This positive x square, negative times x square, negative x square cancels out. Positive 2xy, negative 2xy cancels out. Positive y square cancels with negative times positive negative y square. Right now, what we get then? We get 2hx plus h square okay. Now here from rest of the terms, you see h is common. Let's take that out. What's remaining? This term h square and 2hy. In all those three terms, h is common. Take h out, we get 2x plus h plus 2hy from that 2y plus 2y. This is f x plus h comma y minus f x comma y. Now, in part A, we are asked to divide this by h. So let's divide both sides by h. Divide by h, we get this h to h cancel out, 2x plus 2y plus h. Right? So that's the answer. All right. Now for part B, f x comma y plus k. Um, for that, you replace y with y plus k. Okay, before we go to part B, here you see we divide both top and the bottom by h. That there we assume h is not equal to 0. That's why in the question it's give you that assuming neither h nor k is 0. Uh, in part A, we assume h is not equal to 0 because we divide top and the bottom by h. In part B, you have to divide by k. So uh, try that part B. If you're having any question, let me know. You have my email address. It's the same thing. In part A, we replace x with x plus h. We did not do anything to y. In part B, you don't do anything to x, but you change y to y plus k. Y to y plus k. Right? X stays the same. So this is the x part. It stays the same. Right? Do it, and uh, if you have any question, please email me. All right. Uh, okay. Uh, that's all I have for this one today. Uh, thank you for watching this. Right?